Okay, good evening, everybody. So today we're going to look to continue our class, okay, which is we still in the module 11, and this is the last chapter for the module 11, okay, which is the input interfacing. So let's look on the overview of the input interfacing. So in ARM processor, the pull-up and pull-down resistor are used to ensure that input pin has a defined logic state, either is a logic high or logic low. Okay, means that if you use a pull-up resistor, you're going to make it as a logic high, logic 1. And when you're going to use the pull-down resistor, means that you're going to define a logic low whenever no external signal is applied. So this is very important lah. You need to enable the pull up or pull down resistor every time you use your port or you use your pin as an input pin. So in SKEE32, provide the internal pull up and pull down resistor that can be configured via a software. So this is the inside of this what we call here figure here. Okay, so this is the internal pull up and pull down resistor. By looking at the left hand side here, so this is the pin. Okay, if you can see, this is the pin out for the our processor, the SKM32 processor, and you see here, you can see the what we call here the resistor here, the internal resistor. So since it is connected to the VCC, so that we call it as a pull-up resistor. And this pull-up resistor, if there is no current flow, okay, on this switch here, which means the switch is open, open. So what happened? The VCC, okay, the logic high from this VCC will go to the register, okay, to the IDR register, okay. Compared to the pull down resistor, for the pull down resistor, as we can see, there is a resistor that are connected to the ground. Okay, you can see ground connected to the resistor and goes to your register in your pin. Okay, your pin register, which is the IDR lah. Okay, and this pull down register will be used whenever you use a active high switch. Okay, so when this switch is not pressed, so what happens? The logic 0 from the ground, okay, will go to the IDR input data register, and when this switch is pressed, okay, the circuit will be closed. So the VCC, which is a logic 1 from the VCC, will go to your input data register. So the pull up and pull down resistor is very important whenever you make your port as a input port. So pull up resistor used when the input pin should default to high when not driven internally. So this is where you're going to enable the pull up resistor when your input pin, okay, not to, you're going to driven your input pin as a high, since you use a active low switch, so you need to enable the pull up resistor so that when you not press the switch, okay, the switch here, when you not press the switch, it'll always give you a logic 1. When you press the switch, then after that, it will give you a logic 0. Okay, while for the pull down resistor, okay, it is used when the input pin should default to low. Okay, you're going to make your input always low, okay, when not driven externally. So for the pull down resistor, as we can see here, when this push button is not pressed, okay, it will produce a logic 0 from this pull down resistor. Okay, the logic 0 from this pull down register will go inside the STM32 microprocessor. When the switch is pressed, then after that, logic 1 from VCC will go inside of this STM32 processor. Right. So where you're going to enable the pull up and pull down register. Okay, to enable the pull up and pull down register, there is one register that you need to look at. Okay, that register called a GPIOX underscore PUPDR. Okay, pull up. PU stands for pull up. PD is a pull down, and R is for a register. Right, so this GPIOX PUDPR used to configure the pull up and pull down resistor for the GPIO pins on a specific port. Okay, and this resistor ensure a defined logic level. Either you're going to make it a logic high or low on the pin when no external signal is connected. Means that you not press any switch. When you not press any switch, it will produce a logic depending on the switch that you're going to use. Either you're going to use a what we call an active low switch or active high switch. Okay, and used to prevent the GPIO input pin from floating when no external input is connected. Means that it will always produce a logic high or a logic low when your GPIO input is not connected. Right. For this PUPDR register, okay, there are 32 bits that you need to look at. Okay, started with this one here. This is a PUDPR0. So PUDPR0 is actually for pin 0 lah. Okay, let's say like if you use the port A, so this is for the PA0. Okay, then followed by bit 2, bit 3 is for the PUPDR1. So this is for PA1, followed by PA2, PA3, PA4, until the last bit here is PA15. Okay, for bit 30 and bit 31. All right. So what setting that you need to know here? Okay. So every time you give a value of 0, 0, okay, so there will be no pull up or pull down. Okay, you disable the pull up and pull down. When you put the 0, 1, okay, to this bit, let's say I put 0, 1 here. Okay, I put 0, 1 at this bit 0 and bit 1. So what happened here is now I enable a pull up resistor PA pin number 0. Okay, so 0, 1 is for pull up resistor, while if you give 1, 0, so it will enable the pull down resistor. Okay, contoh, I put a 1, 0 here at pin 17 and 16. So when I put the 1, 0, pin 17 and pin 16, so now my PA8, okay, I enable the pull down resistor at my port A pin number 8, pin number 8. So this is what happened. Okay, so this is where you're going to enable the pull up and pull down resistor at what register? At this GPIOX underscore PUPDR register. Okay, similar. Okay, this register is similar when you use the when you make your output port as a open range. Okay, so here, when you use your output as an open, when you set your output as an open range, then you need to enable the pull up resistor. So where you're going to enable the pull up resistor? At the same register, which is called PUPDR resistor. Okay, so that is for the PUPDR, pull up, pull down resistor. Okay, now we're going to look how to, okay, to do the switch interfacing. Okay, so what is a switch? A switch is actually a simple input device used in embedded system to toggle between two states. So this switch only have two states, either it is on, okay, or okay, every time it's on means that it is in a closed circuit. Okay, when it is off means that it is in open circuit. Right. So there are two types of switches here. Okay, the first one we call it as a active low switch. So what is an active low switch? The active low switch will be trigger an action or input when the signal is low. Okay, means that every time you press the switch, it will give you a logic 0. And if you use a low switch, active low switch, what happens next? You need to enable the pull up resistor. Okay, so active low switch, enable the pull up resistor. Why you need to enable the pull up resistor? Because you need to make sure that if you not toggle the switch, okay, the input will always 1. Okay, when you close the switch, okay, which is when the switch is on, it will produce logic 0. Okay, so this is for the active low switch. Okay, then we have the active high switch. Okay, the active high switch will trigger an action or input when the signal is high. Okay, meaning that when you toggle the switch, your switch in on, right, it will produce logic 1. Okay, and for this one, okay, we need to enable the pull down resistor. Okay, not pull up. Yeah. So please make a correction here. So in this, you requires a pull down resistor. Okay, why you need to enable the pull down resistor? Because you're going to need to ensure the input will remain low. Okay, which is logic 0 when the switch is not toggled. Okay, and figure below here show the pull up, the active low and active high switch. Okay, and this is a common connections lah. Okay, if you have this kind of the connection, then after that you no need to enable the pull up and pull down resistor inside of your STM32. Okay, why? Let's look at the active low switch. Okay, we look at the active low switch. Okay, and by looking at this switch here, you can see this switch here is connected to ground. Okay, and when you close the switch, okay, when the switch is on, it will produce a logic 0. Okay, close switch, logic 0 will enter to the STM32 processor. But if the switch is open, okay, when VCC, okay, you can see here you have a VCC and you have the resistor. So this is actually imitate the pull up resistor. Okay, so this is actually the pull up resistor, but this is outside of the STM32 lah. Okay, previously, what we look at here, this is inside of the STM32. But if you connect your switch, something like this, then you no need to enable the pull up and pull down resistor internally. Okay, because externally you already have the pull up resistor. So what happens here is when when this switch is open, logic 1, okay, from VCC will go inside of your STM32. Okay, and similar to the active high switch, for the active high switch, you can see here, this switch here is connected to VCC. Okay, when the switch is closed, okay, when you toggle the switch, okay, input 1 from VCC will go to the STM32. But when you open the switch, okay, the value from this ground here, okay, so this is the pull down resistor. Okay, pull down resistor will produce a logic 0. Okay, so this is the things that you need to know. All right, so let's look at examples. Okay, an active low push button is connected to PC13. Okay, whenever the push button is pressed, the LED at A pin number 5 will on and off when released. Okay, so now what you need to do? Okay, we're going to draw the STM32 circuit dulu lah. Okay, draw the circuit. Okay, the circuit diagram of your STM32. And then you have PC13. Okay, which is connected to push button. Okay, since my push button here doesn't have a pull up resistor, so I need to enable the pull up resistor internally by enable it at the PUPDR register, right? And then we have the PA5. Okay, so PA5 is connected to LED and assume that this is a common cathode. Okay, so common cathode LED. Okay, so for the common cathode LED, CK LED, what happens here is when you give 0, the LED will off. And when you give 1, the LED will. Okay, now we're going to write the program. Okay, so how to write the program? Okay, as I mentioned, always mention in the class, the first step you need to do is, okay, you need to include this STM32F4 xx.h5. Okay, remember to include this file here. Okay, at least you will get half mark or 1 mark in the exam or in the test. Then after that, after you include the file, okay, we started with the main program. Okay, started with void, main void, open curly bracket, okay, here, and close curly bracket down here. Okay, next, what you need to do? Okay, because we are dealing with the input and output port. Okay, the first thing that you need to do here is to enable the clock. Okay, we need to enable the clock. What clock that we need to enable? Which port? Okay, so in this example, we have a PC13 and PA5. So we need to enable clock at port A and port C. Okay, so that's why you can see here on the very first line, okay, you need to enable the clock at this register RCC AHB 1E and R register. And what value that you need to give? Okay, recall back the AHB 1E and R register. Okay, for this register here, you only need to remember, okay, 8 bits. Okay, the first 8 bits of the register. Other bits you just ignore. Okay, so the first bit, bit 0 here, this is a PA, port A. This is port B, port C, port D, E, port F, G, and H. So this is for the GPIO A, B, C, D, E, F, G, and H. So now, since we are going to enable the A and port C punya clock, so what value that you need to give here? Okay, we need to give port A with 1, and then port C also 1. Okay, and then the rest of the bit, okay, you just give 0. Okay, so hence the value here that you need to give is 0x05. Okay, according to the AHB YNR register that we already initialized. Okay, that we already set here. All right, next, what we need to do? Okay, the second step. Okay, once you enable the clock on your GPIO port, the second step here is to set the port either as an input port or as an output port. Okay, and in this example here, port C pin 13, okay, you need to make it as an input port, while port A pin number 5 means you need to make it as a output port. So how to make it as an input and output port? Okay, to make it as an input and output port, you need to enable it at the mode R register. Okay, so this is the mode R register. GPIOA model. Okay, so what value that you need to give to your GPIOA model? This value lah, 0000400. Okay, why? Because you're going to enable, you're going to make your port A pin number 5 as a output port. Okay, and remember back the GPIO model punya register. Okay, I don't want to draw the register. Okay, I will scroll the register here. Where is the register? Model register. This is not input, output. Okay, so this is the model register. Okay, as we can see here, okay, port A pin number 5 is at this location, model 5. Okay, so what value that you need to give to this model 5? So you need to give 0, 1. Okay, give 0, 1 to this model 5 to make it as a output port. What else? What about other models? Other models, you just give 0. Hence, when you convert the value, okay, it is equivalent to 0, 0, 0, 0. So this is for the higher 50 bit, and for the lower 50 bit is a 0, 4, 0, 0. Okay, and this is the value that you need to give to the GPIOA model. Okay. Right. Next, once you initialize your port A as output port, the next thing that you need to do here is, okay, is the output can be in 2 modes, either a push-pull or open drain. Okay, so we always want to make it as a push-pull output port. So what you need to do here, okay, we need to give a 0 to that O typer. Okay, so that's why you can see here GPIOA O typer n equal to tilde OX 0000020, okay, which is to set a PA as a push-pull. Or you can simply write down like this GPIOA O typer equal to 0. No problem. Just like that. Okay. Then after that, all port in the port A will be assigned as a push-pull. Okay. So port A is finished. Okay, we already initialized the port A as our output port. Then now we are going to initialize C as a input port. So how to do it? Okay, you can write down. Okay, again we need to set it at the model register. Okay, since it is a port C, so that's why the register we're going to use here is GPIOC model equal to n equals tilde OX 0400000. So this is a value for pin number 13 in mode register. Okay, or you can simply write like this Okay, if you don't want to write this coding here, you can simply write GPIOC model equal to 0. Okay, means that you make all the port C as a input port. Okay, as long as the PC30 is made as an input port, so I will also accept this puts here. Okay, and next, after you initialize your GPIOC as an input port, the next step is you need to enable the pull up register or pull down register. Okay, register. So here, since this is a active low push button. So for the active low push button, what resistor that you need to enable internally? Pull up or pull down? Ama, pull up or pull down resistor?
Pull down.
Okay, we need to enable the pull up resistor lah. Why pull up resistor? Not pull down, eh? Why pull up resistor? Because we use the active low switch. Okay, every time you use the active low switch, you need to enable the pull up resistor. Okay, when you use the active high switch, you need to enable the pull down resistor. Why? Because for active low switch, okay, when you not press the button, okay, you can see here from this circuit here, when you not press the button, it will always produce logic 1. Okay, it will produce a logic 1 when you not press the button. So how to do it? By enable a pull up resistor. Okay, so how to enable the pull up resistor? You need to enable a PUDPR. Okay, so we go back to the PUDPR. Okay, so this is the PUDPR punya register. And now what we're going to identify what would be the value. Okay, for this PUDPR. Okay, since the switch is connected to port C pin number 13, so you need to look at the PUDPR 13. Okay, at this location. Then after that, you need to identify what value that you're going to give. Okay, pull up resistor, you need to give 0, 1. Okay, according to the pull up resistor, the value that you need to give to PUDPR 13 is 0, 1. So you simply write down 0, 1 at this bit, while the remaining of the bit you give 0. Okay, so put others bit with 0. And then you change it to hexadecimal. Okay, I assume that all of you already know how to change it to hexadecimal. So you just make it as a 4-bit group. Okay, by using the 8-4-1 method, the one will give, okay, bit 28 until 31, you get 0. Meanwhile, 24 to 27, you will have 4. This one also 0, 0. Down here also 0, 0, 0, 0. Okay, so the value that you need to give to your PUDPR would be 0, 4, 0, 0, 0, 0, 0, 0. Okay, so that's why you can see this is the value. Okay, 0, 4, 0, 0, 0, 0. Okay, to enable the pull up register at port C pin number 13. Okay, after you finish initialize the clock of the GPIO, okay, make the selection of the port as an input or output port, okay, then enable the pull up resistor or pull down resistor. Next, after that, we're going to write down the programs, okay? So using the while one, okay, because we're going to do it continuously. Okay, we're going to monitor the switch. Either the switch is pressed or not continuously. So that's why we use the while one. Okay, and then what you need to do? Okay, so we need to check lah the value of the apa ni kita panggil the value of the input data register either this push button is pressed or not. Okay, so here this is how you're going to do it. Okay, if GPIO IDR, okay, looking, because this is an input, we're going to look at the input data register. Okay, so input data register, and then and with one shift to the left 13 times. Okay, kenapa satu shift to the left 13 times? Okay, because we're going to look at this bit number 13. Why bit number 13? Okay, we go back to the IDR register. Okay, so kita go back to the IDR register. Where is the IDR register? It's not IDR register. Oh, typer. Okay, IDR. Okay, so this is the IDR register. Okay, so inside of the IDR register, only 16 bit is required. Okay, you need to know only 16 bit, and each of the bit here you can see IDR0. IDR0 is for the pin 0 lah. IDR1 pin 1, IDR2 for pin 2, and IDR15 is pin 15. Okay, now we're going to look at, because the push button is connected to pin 13, so we need to look at this IDR 13. Okay, you need to monitor lah. This IDR 13, either it is 1 or 0. So every time you will be going to monitor the switch, we need to make a masking value. Okay, so the masking value will be 0, 0, 1, 0, 0, 0, 0, 0. For all other bits, okay, we just simply give 0. And then by using the 8421 method, okay, you need to find out the value lah. Okay, the value will be 2000, and then above here also 0 lah. Everything will be 0. Okay, so this is your masking value. Okay, actually the masking value will be OX2000. Okay, or you can simply use the shift 1 to the left 13. Okay, so how it will okay, macam mana it works? Okay, you have number 1, shift to the left 13 times. Okay, 13 kali. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. See, the number 1 now go to this bit, the same bit as the IDR 13. And it will produce the same value lah, 0, 0, 1, 0, 0, 0, 0, 0, 0. Okay, in hexadecimal, the value still will be 0x20, 0. Okay, so this is how you're going to monitor. Okay, we're going to compare whatever value inside the IDR with the masking value, and if apa ni kita panggil, if the switch is pressed, okay, if the push button is pressed, it will produce a logic 0, correct or not? If the push button is pressed, okay, according to the circuit here, okay, when the push button is pressed, okay, when you press the push button here, it will produce a logic 0. Okay, so that's why we compare it with 0. Okay, GPIO IDR, and with the mask value, okay, which is 1 shift to the left 30 times, ataupun you can use 0x0, 0x2000. Okay, is it equal to 0? Okay, so this one here you're going to check lah, is it pressed or not? If it is 0, so what happens? It says that when the press, LED will turn on, the PA5 will turn on. So how to turn on the PA5? By give a value to PA5 at output data register. So that's why you can see here GPIO ODR equal to what value? To enable the to on the PA5. Since this is a common cathode, to on the PA5, you need to give 1 lah, dekat PA5. To on the LED, give 1 to the PA5. So this is the value of the PA5, which is equivalent to 0, 0, 2, 0. Then it will turn on the LED. If the value inside the IDR, okay, the IDR 13 is 1, okay, so it will not equal to 0 lah. So what happened? The apa ni kita panggil, the LED will turn off. Okay, so that's why GPIOA ODR equal to 0. Okay, you can simply put GPIOA ODR equal to 0. No problem. Same thing with this code here. Okay, I will still accept if you write down this one. Okay, so this is how to monitor lah the switch, the push button switch that you put at PC13. When the switch is pressed, LED will light up. Switch is released, LED will turn off. Right. So we have another example. Okay, but this example here is using the active high push button. Okay, so active high push button, the same thing, the same example, but in this example, it used the active high push button. So PC13 connected to active high push button. Okay, active high means that you need to connect to VCC, and since your push button you draw without the what we call here pull down resistor, so you need to enable the pull down resistor internally by enable it inside of the PUDPR register. Okay, so here we have the PA5 connected to the LED as well. Okay, same thing. Okay, so we do the same things as above, as the previous examples. Okay, include the file and then enable the GPIO A and GPIO C clock. Then after that, GPIO A model, you need to make it as an output port, and then make it the odd typer as what we call here. Make the output as a push-pull. Okay, don't use the open drain. If you use the open drain, then after that you need to enable the pull-up resistor at this GPIO as well. All right. So then after that, make the GPIOC as a input port. How to do it? So just give 0 to your model of the GPIO C. Okay, just give 0. Then after that, your port C will become an input port. And after you make it as an input port, then after that you need to enable lah. Enable what? Okay, since this is a active high, so active high, we need to enable the push pull down resistor. Okay, so pull down resistor, what value that you need to give to your PUDPR? Okay, we go back to the PUDPR. Okay, previously, okay, the what we call here, the fish still connected to port C pin number 13. So you need to look at this PUDPR 13 lah. Okay, and what value that you need to give to this bit 26 and bit 27. All right, pull down is a 1, 0. Okay, when you put a 1, 0, now the value change from 4 to 8. Okay, so only at this value here is change. Okay, you need to change at this value only. What about the rest? The rest still same. Okay, you can look here. This is where you're going to monitor the port C punya switch, either is a 0 or not. Okay, if it's 0, then after that the LED will light up. If sorry, Okey, sekejap. Kalau 0, okay, so this one is terbalik Sorry, the jawapan here is wrong. Okay, so when the value is 0, then the LED should be turned off lah. So instead of you give 0020, you need to give 0 lah here. Okay, so this will turn off the LED. And when the value is 1, okay, then after that, okay, you need to turn on the LEDs. Okay, I just. Okay, so this one here is 0x00000020. So this will be turned on the LED. Okay, so only this one here you need to change lah accordingly. Okay, to turn on and turn off. Okay, so that is for the switch. Any question up until here? Ada soalan tak for the switch? Before we move on to another input interfacing. Any question for you guys? Okay, if no question, then we move on to the DIP switch. Okay, what is a DIP switch? The DIP switch consists of multiple small of switches in a single package. Okay, previously we have only one switch, and now you have multiple switch in one package. This is the look of the DIP switch. Okay, when you buy the package, for some time, it will have consist of at least 8 switches that you can choose from. All right. So each switch has 2 positions. All right. There are the 2 positions here. Either on, okay, which is you're going to close the circuit, or open the circuit. Okay, when you strike this switch here to on, which is you're going to toggle the toggle on, the switch connect its pin to an electrical signal, which is it will give you logic 1 or logic low according to the type of the switch that you're going to use lah. Okay, if you connect the switch to the ground, means that it is an active low switch. When you toggle it on, it will give you logic 0. Okay, when you connect this switch to VCC, now it become an active high switch. Then whatever, when you toggle on this switch here, it will produce logic 1. Okay, so the toggle off, it disconnect the circuits, means that it open the circuits, leaving it open or connected to a default state, which is via pull up or pull down resistor. Okay, again, remember active high. Okay, active high, we always produce logic 1 when the switch is toggle. Then if you're going to produce logic 0, you need to enable the pull down resistor. Okay, this is for the active high. If you're using the active low, okay, when you toggle the switches or you push the push button, all right, it will give you logic 0. And to make it logic 1, you need to enable the pull up resistor. Okay, so only remember this thing here. All right. So that is for the input interfacing. Any question, Amati here? So every time you use the switches, push button, ataupun you have the DIP switch, the mechanism is same. Okay, either you're going to use active high or active low. For active high, enable the pull down resistor, while active low enable the push up resistor. Okay, now we're moving on to the how to generating a delay. So there are 3 ways to generate a time delay in ARM processor. Why this delay is needed? Because if you're going to turn on and turn off LEDs, or you going to turn on the lamps, okay, you need to generate a certain delay so that your lamp or LED will turn on in specific duration. Okay, depending on how large the delay that you are created. Okay, so how to generate this delay? Okay, first we can use a loop. Okay, you can use a for loops, while loops to generate a delay. But by using this loop here, the delay that you will going to generate is not that accurate lah. Let's say if you're going to generate a 1 second delay, you did a for loop, maybe the delay that will be generated is maybe less than 1 second or more than 1 second. It's not at the exact time. Okay, and then we can use the predefined functions. Okay, the second one is predefined function. So this one here, you can use the delay underscore ms and put the value inside of the how long delay that you're going to generate. And this one here more accurate lah. Okay, the predefined function is more accurate. If you're going to generate a 1 second delay, it will generate 1 second delay, right? Precisely 1 second delay. And then we have the hardware timer. So this is another way lah to generate a delay, and this also very accurate and very precise. Okay, but you need to do a sum of calculations, and then after that you need to do a sum of coding to generate the delay using this timer, hardware timer. All right. So now you're going to look at how to generate delay using the loops. Okay, using a loop is a simple way to create a delay by executing a software loops. Okay, this method is straightforward but not precise. Okay, as I mentioned earlier, the delay that you're going to generate is maybe lower than how the duration that you're going to you need it. Okay, the duration that you want. Okay, and this delay is depend on the CPU clock speed and compiler optimization. So these examples are how to generate a delay. Okay, you have the subroutine of the delay here by using a for loops, and then inside of the main program, okay, you just call the subroutine. Okay, so this is using the loop. Okay, and the second one here is using the predefined functions. So in SKEE32, it has a libraries like SimSys or Hall. Okay, you can use the SimSys library or hardware abstraction layer. Okay, predefined delay function. Okay, that available in this SimSys or Hall. Yeah? Okay, and this typically use the system timer. Okay, sometimes we call it as a stick. Okay, 4 millisecond level delay. Okay, and this is the ni lah dia punya ni the predefined function. You just put a delay underscore ms. If you put 500 inside here, means that you're going to generate a 500 millisecond delay. If you put 1,000 inside of this bracket, so whatever you're going to generate a 1,000 millisecond delay, which is equivalent to 1 second, right? Okay, so that's it for the delay duration. Okay, for the timer, we will not cover on the hardware timer because this one here we need to have a special topic for that. Okay, for the timer, because to generate a delay with using the timer is quite long. Okay, you need to know what register to use, how to calculate the delay, and then and after that how to do the programs. Okay, how to write the programs. Okay, and for MSI device, okay, I will not cover on the MSI device for this semester.